Hi, welcome to another episode of CITV. In this video, we will show you the masons finishing off the stem wall and filling the hollow CMUs, blocks as you may know them, with concrete. We will show you the site being backfilled with soil, then compounded and made ready for the MEPs, which is basically the plumbing and electrical that's going to sit on the top of the subfloor. Well, actually in the middle of the subfloor, and I'll explain exactly what I mean during the following segment. I was hoping to show you the MEPs being laid out on the site in this episode and then the concrete slab being poured on top. But unfortunately, the construction set of plans has been delayed, and this has had a knock-on effect time-wise, which is very disappointing, to say the least. But I will deal with that in a separate video at a later time. Anyway, sit back for the next 15 minutes and continue following the journey of the 3 magnificent townhomes we are building. Oh, and don't forget to hit the subscribe button and the reminder bell below, which will notify you whenever we post a new video to our channel. In the last episode, we left you with the stonemasons erecting the stem wall, which is part of the foundation which will support the 3 townhome structure. As you can see, the stem wall foundation is finished. Plumbing and electrical will be laid out in a plan on the ground in conduit piping. Concrete will then be poured over it to form a slab, with the plumbing and electrical encased. Some stem wall blocks have been left hollow and not filled with concrete, so plumbing and electrical can be threaded through to the superstructure, which is the construction above ground. We will explain this in better detail in a minute. And for our mutual pleasure and just for fun and giggles, we have overlaid the ground architectural plan, as you can see here, to see how this Lego set is coming together. I still prefer Meccano. The site workers here are connecting 6-inch rubber hoses together from the concrete truck. Funny, in the UK we used to call it a cement truck. Very confusing. Anyway, the day has arrived for concrete to be pumped into the hollow concrete masonry blocks, CMUs for you professionals, to make them totally robust. The nozzle is aimed and pointed at the CMUs, and the filling begins. Hi, I'm with Christopher Stanton. Here's the supervisor for the project. Christopher, or yes, Chris.
Sir. Yes, sir.
Tell me what's going on here.
So today we are doing a stem wall pour, about 20 yards of concrete, fairly small, fairly easy. We're filling up these empty concrete blocks that'll tie into what's the slab, which you know as the floor of the place. So this dies us in to the slab, secures the foundation, everything to the footers. We got to come back and fill all this up with dirt, get it nice and level, and then we'll pour a nice concrete topping over the top, over the piping and sewage lines and electric, and that'll be your subfloor. That'll be pretty much what we build the rest of the house off of. So this is a very crucial step.
So when is the MEPs going in, which is what you're just about to, what you're talking
about?
Well,
MEPs, we have, you might be able to see over there, we have small little sleeves or poke throughs. Maybe you can even see this here, this little P on this block.
Yeah.
That's a plumbing P.
Yeah.
So we come out, we fill that with sand so that the plumber can come back later and not have to cut all that concrete out to run his lines through the length of the house and out of the house for sewage and electric and irrigation, any other thing that we have.
So I was speaking to Joe's, the shell contractor. He said that we got a compound here as well. Get the density right. Yep. And that gets surveyed as well, don't they? They do core samples and whatever. Yeah.
They will do density tests on the on the slab compaction, yes.
Right, and also geological test in terms of actually the composition of the dirt, right?
So they did that before we started building here. What they do is they came out with a boring machine. They go about 20 feet deep into the lot, pull soil samples so you can determine what exactly the ground in the surrounding area is made up off of. And then based on that, they tell us how and which method is most efficient for compaction.
All right, the slab, 3 weeks.
You got to figure maybe a week and some change to level all this out. Slab formation should start within probably 2 weeks. It should be.
Okay,
we have to layer a lot of rebar. There's a lot of rebar going in the slab. We have to do all the plumbing. They poke through, but they have to come up and land in your kitchen, land in your bathroom, land in your shower. So that takes a little bit of due diligence.
Sure. Okay, well, we'll be back for that anyway, and we'll see you soon. Chris, thank you very much for helping us out.
Thank you.
I got a sweaty handshake, but you should be used to that.
That's all right. That's all right. That's about as sweaty as I get because I don't work too hard.
Okay, lovely. Thanks very much.
Thank you.
I'm with my good friend and investor, John Harmon here. He's come down to the site to see what's going on. John, what is the material difference between what goes on here and what goes on in Northampton?
It's very similar, but
Yeah.
a lot hotter here.
Yeah.
And,
Yeah, really?
Yes, and obviously you build out of concrete block and we build out of block and brick, but otherwise very similar.
And so you used to, it's all this sort of like the footings. You called it something else the other day, didn't you? You called it, what did you call it in England?
Yeah, the substructure.
Yeah.
But yeah, very similar.
And you do the same thing, you build like a wall and then you cement it in.
We do, yes.
Concrete it in,
Yes.
concrete it in.
We do, but we don't have all the steel because obviously we don't have hurricanes, so...
Yeah, sure, no, I appreciate that.
Yeah.
And so, like, obviously we're going to pour the slab in about 3 weeks' time, and then that's the same thing that you do in London, you pour it as
Yes.
well, don't you?
Yeah.
But then over here, what we do, and I don't know, and listen, I've never been to England in my life. The subfloors, subfloors, the first, second and third floors,
Yeah.
we put hollow core in, so it goes together like a Meccano set or Lego. And do you have that, is that how they build them in the UK?
Normally out of timber, but sometimes hollow core, yes.
All right, so that's, okay, all right.
It's very similar, yeah.
All right, well, look, how many houses do you build a year? Come on, you can tell them, don't be bashful.
59 this year.
59 houses. That's 56 more than I built. Anyway, John, thanks very much for coming down. We're going to see more of him as we go through the build. John's going to be out of here, please God, 6 months a year, so we're going to have lots of fun together, champagne and caviar and all those good things, yeah? Thanks for have a sweaty handshake on me.
Yeah, thank you very much.
There you go.
Thank you.
Wasn't too
That is
difficult,
sweaty,
was it?
Tony. That is sweaty.
So here we are a couple of days later. All the hollow CMUs have been filled with concrete, and as mentioned before, some have been left filled with sand so the plumbers and electricians don't have to chip away at the concrete when they are threading through the utilities.
Unfortunately, I can't show you the soil being backfilled onto the site and compacted, as nobody informed us this was going to be done yesterday, but hopefully the second course of soil from around the edge of the site will be backfilled and compacted over the next few days, and I hope, if informed in time, to show you that. So why compact the soil? It's all about moisture. Moisture has a huge influence on soil, including how it is compacted and the compaction results. Compacted soil must support a heavy load through all weather conditions. For example, rain, which it's going to do any minute now, can transform soil into a plastic state or even a liquid. Now, when that happens, sand loses its load-bearing abilities. Perfect compaction relies on perfect moisture content. You see, moisture acts as a lubricant within the soil, sliding the particles together. So each type of soil will react to different moisture content. Not enough moisture equals inadequate compaction, therefore no load-bearing ability. And too much moisture equals inadequate compaction and therefore weak load-bearing ability. So our engineer has determined the optimum moisture content that we need for this site. And the testing of a core sample, which happened today, again, which I missed, will determine how close we are to that number. Well, what's going on behind me today, which is a day later after obviously I filmed the last segment for this video, is that the dozer is flattening out the site and taking the piles from around the side here of the site and backfilling into the ground. And just, they will later on, I don't know if I'm going to have time to capture it on video today because I'm running a bit late for a meeting, but they'll come along with a compactor, and I hope to show you that perhaps either today or tomorrow. But they'll keep on compacting the ground, so they keep on taking the dirt from around the edge, backfilling it into the site here, and then compacting it and trying to get the right density as outlined by our engineer in their report. As you can see, they're already up to about 2 courses of brick at the moment, or a CMU as it is, and they've got another 2 courses of dirt to put on to backfill into this site. And so hopefully what you see protruding now will be completely covered and will be level with the dirt. Eventually this whole site will be level once they put all the courses on. I've got a feeling they're going to have, well, I actually know they've got to bring in some more dirt from elsewhere. There's not enough dirt around the outside of this perimeter. So as I said, eventually it's going to be completely level. We're then going to put in the all the MEPs, which is the plumbing, electrical, and then once that on the ground level, and then once that's done, then we're going to put in the slab, which is basically a whole layer of concrete. So eventually this whole floor level site will be concrete. As I said the other day, it's just such a pity that you're seeing the groundwork as it is now, and you didn't see the entire backfill process going in from all the dirt that was surrounding the site and put into this, what is basically a hole, and then smoothed out and then compacted. But hey ho, it is what it is. It's only going to get higher, flatter and smoother.
So a few days later I got a call from Chris Stenton, the site superintendent. He said, "Tony, get the camera down here quickly. There's some parts of the site that are being backfilled now that will show your viewers exactly what you were trying to convey a few days ago, including showing how the compacting is done to get the right density." And as we were filming, nutting engineers turned up and did a density test of the newly compacted ground. It showed the desired 98% compacting that we needed, so we could carry on with the backfilling. Oh well. All's well that ends well, as they say.
That's all for this episode. In the next video, but one, and I will explain that in a minute, we will show you the MEPs being laid on the site floor, and then the concrete slab being poured over the top. Or rather, it's the concrete being poured over the top that makes the slab. Anyway, but before we publish that episode, we have a bonus episode that we will be uploading to our channel at the end of the month. As you're aware, if you are a regular viewer or even an irregular viewer, we have had sewer pipe issues. Like we can't find one of them. So we revisited the problem with a plan of action. And even if I say so myself, this is going to be a very interesting episode. So look out for that. As I said, it will be uploaded around the end of this month. Don't forget to hit the subscribe button and the reminder bell below, so you are always kept up to date with the construction, dare I say it once again, of these 3 beautiful townhomes. Thanks for watching.